So we're given an integer array nums. They want us to return true if any value appears at least twice. Otherwise, just return false if all of the elements are unique. So if we look at this example, the output is going to be true for this array because we have two ones in it. So we see a 1, we see a 2, we see 3, and then we see a 1, but we already saw a 1, so we return true. Otherwise, we return false if every element's unique. So we have a 1, a 2, a 3, a 4, and then we just return false because there's no duplicates, and so on and so forth. So we're going to want to be able to solve this in big O of n time, right? So we know in the best case, we'll have to at least look at each element, right? We need to know what each element is. But we want to do that linearly, right? So we need a way to remember what elements we've already seen. So for our space complexity, we're going to have linear as well, because we're going to use a set to store all of the elements that we've already seen. And we're going to have big O of 1 lookup time on the set to check if an element exists, right? So big O of n time, big O of n space, where n is the number of elements in the input array. So let's do that example on the first test case there. So we have this array, and say we're at this one, right? And we'll have a set over here. So we're going to do two things. We're going to check if the 1 is in the set, right? If it's already in the set, we can return true, right? We have seen a duplicate. That's all we're worried about. After that, we're going to save the element to the set. So otherwise, we'll just save it and we'll move on, right, for later. So we have the O of 1 lookup time on that element, on all of the elements that we've already seen, right? So we'll check, is the 1 there? No. So we'll add it. Then we'll move our iterator. We'll check, is 2 there? Nope. Okay. So move the iterator. We'll check the 3. It's also not there. And then finally, we check the 1. It is there. So we'll return true. So otherwise, we just return false if we get to through the entire, all of the numbers and they all turn out to be unique, right? That's where we'd get that big O of n space, and that's where we return false. So yeah, so let's code that. We're going to need a set. So in C++, that's just like a unordered set. We're going to put the type. So it's just going to be an unordered set of integers. We'll call this num set. And we can then loop through nums. So if we're going to say, for const int num by reference in nums, and then, oh, I don't know why I did that. In nums, just the spacing's off. Or the indentation, rather. Okay, there we go. So for num and nums, we're going to first check. So if num set dot contains, so that's just going to check, is the num in our set? If it is, then we can just return true. Otherwise, we have to say num set dot insert on num, and that'll just put it into the set that'll save it for later for the constant lookup. Then we can just return true, or return false. So hopefully that helps. If it did, leave a like, and I'll see you guys in the next piece.